Hello everyone and welcome to the SNOMED CT-AU and AMT subsets webinar. This webinar assumes some basic knowledge of SNOMED CT and its components, including descriptions and relationships. If you'd like to know more about SNOMED, we have some introductory webinars available on the agency YouTube channel that you can watch at any time. The learning objectives from today's session are to describe why subsets are useful when working with terminology, to compare the features of reference sets and value sets, to explain at a high level how subsets can be implemented, and to provide examples of subsets available from the National Clinical Terminology Service or NCTS, the use cases they support, and also how to access them. So to start, what are subsets? Subsets are a group of concept representations that come from standard vocabularies. These vocabularies might include SNOMED CT, LOINC or ICD, or even more targeted or use case specific ones like Meteor or Australian Immunisation Register codes. They provide additional value to terminology and to users by bundling useful codes into a package or group that represent a clinical concept or domain. For example, a subset could be a group of codes that represent the days of the week or the states and territories of Australia. They are most often used to constrain the content of a coded data element or data type property in an information model. So for example, the adverse reaction agent reference set could be used to specify values in a pick list on a user interface, or be used to indicate the permitted values in a specification for information exchange. Subsets can range in complexity from a simple flat list of codes from a single code system up to a hierarchical set of codes pulled from multiple code systems. They are available in two main formats on the NCTS. The first is reference sets, which are subsets that contain only SNOMED CT components and conform to the SNOMED CT specification. And the second is FHIR ValueSets, which conform to the FHIR specification. Let's look at what a clinician might see when they are entering information about allergies and adverse reactions into a clinical information system. There may be a few different fields on the screen, and each of these is capturing specific information, so is bound to a specific subset. In the picture, we have a search function for clinical manifestation, which describes the signs and symptoms of the reaction. And when you search for rash, it only brings up options that are within the clinical manifestation reference set. This is probably one of the most common methods of implementing terminology in a search function. Other fields that are coded are reaction type, and this one can be a drop-down pick list because the number of options are small, and causative agent, which again is a search function and can be further constrained to subsets like agent, medicinal product, and trade product. Now let's have a look at how subsets are bound to national specifications. In the shared health summary example we see here, when recording an adverse reaction, the permissible values to record the substance or agent causing the reaction come from 9 reference sets. It specifies that the value must come from the adverse reaction agent or substance foundation reference sets from SNOMED, or from any of the 7 notable concept reference sets of AMT. So why use subsets available from the NCTS? The NCTS publishes several reference sets to help with implementations, and there are a number of reasons why you may wish to use subsets that are available here. For SNOMED and AMT content in particular, they provide small usable chunks of terminology that can be implemented within a clinical system to suit a given use case. Our subsets are developed and maintained within our terminology quality assurance processes, and in some instances are co-developed in collaboration with external subject matter experts. As an example, the adverse reaction agent reference set was developed by mapping data from a number of jurisdictions to determine what content should be added. Where appropriate, we use relevant source data to develop subsets. So for example, taking a data feed from the TGA to ensure that our Schedule 8 medicines reference set contains all the Schedule 8 medicines. Subsets may also provide information that is not otherwise contained within the terminology. For example, the Australian dialect reference set is used to indicate which synonyms are preferred and acceptable for use in the Australian healthcare environment. They also provide the opportunity to define content that is not within the scope of SNOMED or AMT. So for example, we have published a FHIR code system of the Australian Immunisation Register vaccine codes because they're commonly used in clinical practice. These codes don't belong in SNOMED or AMT, but because they're used for recording and billing purposes across the country, the FHIR code system allows us to formally define and publish this subset for national use. The NCTS hosts reference sets that are owned by SNOMED CT-AU license holders, and these are called third-party reference sets. These subsets are developed by a third party for a particular purpose and then hosted on the NCTS to allow broad implementation. An example of a third-party reference set is the Tasmania Reportable Trade Medications reference set. And this subset was specified by the Department of Health and Human Services Tasmania to support the electronic recording and reporting of controlled drugs. By publishing this reference set on the NCTS, it allows for dispensing system vendors to use it as a part of the real-time reporting initiative. Finally, reference sets are available in a variety of formats to support different implementations and are published with a concise description to help identification and selection. Let's take a look now at the types of SNOMED CT-AU and AMT subsets. So how do you know which subset type to choose? The type of implementation will determine which type of subset is most appropriate. The purpose and intended use of the subset can also impact subset choice. As an example, if you had a native implementation of SNOMED CT-AU in a clinical information system, then reference sets would be most appropriate. Whereas if you had a FHIR implementation that was needing particular subsets to conform to agency FHIR specifications, then FHIR ValueSets would be appropriate. Note that not all subsets are available as both reference sets and value sets, and we will talk a bit more about that later on. When it comes to determining which subset to use, you'll also need to understand the content and scope of the subset to determine whether it's relevant for your use case. As mentioned before, we publish documentation that describes the subsets to help with this. Now I'll run through some examples of subset content on the NCTS, starting with reference sets. I'll first briefly recap what SNOMED CT is. At a high level, SNOMED CT is a large dictionary of clinical terms in the sense that it contains concepts with meaning that is designed for clinical data capture. It's very comprehensive and currently contains over 350,000 concepts covering large content areas such as diseases, procedures, clinical findings, body structures, substances, and therapeutic products, plus additional content that helps define the meaning of these major content areas, or what we call qualifiers. SNOMED CT-AU is the Australian extension of SNOMED CT. It contains SNOMED CT international core files plus Australian-specific documentation and terminology, such as the Australian Medicines Terminology, or AMT, the Australian Dialect Reference Set that contains spelling or other preferred naming conventions we use in Australia, and many other reference sets for clinical use that I'll talk about later. So, what are SNOMED CT reference sets? Reference sets are extensions to SNOMED terminology for a specific purpose. They identify subsets of content and support a range of granularity and specificity. The most common reference sets are subsets, where we create small bite-sized chunks of the terminology to help with implementation. However, there are other types of reference sets, such as mapping or association reference sets, where information can be added to the terminology that's not already part of the modelling. We will go over these broad categories next. Of the reference sets published on the NCTS, the 16 foundation reference sets contain the broadest possible terminology content because they contain all concepts within a top-level hierarchy. For example, looking at SNOMED CT-AU, all concepts in the procedure hierarchy are contained within the procedure foundation reference set, while all concepts in the clinical finding hierarchy are contained within the clinical finding foundation reference set. For AMT, each of the 7 notable concept levels of the model is also represented by a foundation reference set. For example, the medicinal product reference set or the container trade product pack reference set. Foundation reference sets support use cases where broadly related sets of codes might be required. So as an example, the procedure foundation reference set could be specified in a data element that captures a surgical intervention. They can also be used as a base on which further constraints can be applied, which would involve using more than one reference set in combination to produce a set of codes that fit a particular use case. Broad context reference sets provide a broad set of terminology within a clinical grouping. For example, the cardiovascular finding reference set includes all clinical finding concepts that describe a cardiovascular related finding. Broad context reference sets are useful to represent terminology for a particular clinical grouping or a theme. So as an example, the mental health disorder reference set could be used in a data element that captures a mental health diagnosis. As with the foundation reference sets, broad context reference sets can be used as a base to create a set of codes suitable for a particular clinical setting or professional group. Language reference sets are most commonly used to indicate which description or synonym is preferred or acceptable in a particular context. An example is the Australian dialect reference set, which specifies descriptions as either preferred or acceptable in the Australian healthcare environment. A language reference set could also be used to specify a description preference within a specific clinical specialty. Mapping reference sets allow a representation of the relationship between concepts in different code systems. They are most commonly one-to-one relationships, and each of these relationships may state that a code in a source code system is equivalent or perhaps not equivalent to a code in a target code system. More complex map representations are possible, including one-to-many or many-to-one relationships. In the SNOMED CT-AU release bundle, there are two mapping reference sets currently available. So the Australian Register of Therapeutic Goods Identifier or ARTGID reference set, which links one or more ARTGIDs to a container trade product pack concept, and also the substance to SNOMED CT-AU mapping reference set, which links AMT substances with SNOMED CT substances. Now looking at some of the more use case specific examples of reference sets that are available on the NCTS. First of all, the adverse reaction reporting related reference sets support the recording of the agent that's responsible for an adverse reaction, as well as the type of reaction and the clinical manifestation or the signs and symptoms of the reaction. The dose-based prescribing related reference sets support non-product-based prescribing or ordering of medicines. And this type of ordering is typically performed in hospital settings and allows specification of a medicine dose form, frequency, route of administration, and course type. The AMT concrete domain reference sets, such as the strength, unit of use size, unit of use quantity, and the subpack quantity reference sets, support the defining of numeric medicine attributes. These reference sets allow for the association of a concrete or numeric value with a component. Let's talk a little bit about the traditional format of a simple type reference set, in this case, the adverse reaction type reference set. This reference set supports the recording of the type of adverse reaction experienced as determined by the clinician. Here are screenshots of a couple of different versions of the reference set that suit different purposes. We won't go through all the details. It's here so you have an idea of the structural differences between a reference set and a value set. The main points to take away are that in the picture in the background is the release file or RF2 version of the reference set, which is used for implementations. Reference sets have an identifier, in this case 110000361103. Also, the last column contains the reference to the concept ID, which itself is held in its own separate table, hence why it's called a reference set. Finally, you'll notice that there are only codes in the table because they are optimized for implementations. The descriptions are held in another table so that the release files aren't human readable. Because of this, we also publish a TSV version of these reference sets, which is the screenshot in the foreground. It can be loaded into Excel and contains the concept ID and the descriptions associated with it, so you can more easily understand the members of the reference set and assess whether it meets your use case. So how do we work with reference sets? Several reference sets can be used at once, and you can use combinations of reference sets to get the data that you need. For example, instead of using all concepts, you can filter with a grouping reference set, such as the clinical finding reference set, which gives you the concepts you need, shown in the grey circles. You can then join the descriptions table to get the human readable terms in the second column. However, you then need to overlay the Australian dialect reference set on the descriptions to get the preferred terms, which are the purple rectangles. One way to refine reference sets is to create custom intersects. For example, you start with the emergency department diagnosis reference set, but you only want the concepts related to fracture. So you would use the fracture finding reference set to narrow down the concepts you want to the green circles. You can use this method to create your own reference sets for your implementation. So that is, you start with those that are available nationally and then customize it based on your requirements. If you're interested in developing your own reference sets or customizing reference sets for a particular purpose, please get in touch. We're happy to provide guidance and help where possible. Let's take a look at some examples of value sets on the NCTS. A FHIR value set is the second type of subset we'll be looking at today. FHIR stands for Fast Healthcare Interoperability Resources and is a HL7 standard for electronic healthcare data exchange. One part of FHIR also specifies how terminology can be managed. There are 3 FHIR resources that are used in terminology, so code systems, value sets, and concept maps. A value set specifies a list of codes taken from one or more FHIR code systems for use in a particular context. Each code system has a globally unique URI and can be referenced by any number of value sets. For example, a value set may constrain a small set of codes from a larger code system, or may be used to extend a code system by combining codes from another. The third type of FHIR resource is the concept map, which describes the relationship between codes in 2 or more value sets. The key purpose of a value set is to specify the allowable content for a coded data element. So for example, in the agency's shared health summary specification, the adverse reaction substance or agent specified must be a member of the adverse reaction agent reference set. The value set resource can also be used to give context to a concept map resource, which describes the relationship between codes in different value sets. So as an example, a concept map may be used to show that code X in a historical value set and code X in a current value set are equivalent and mean the same thing, and it allows interoperability despite someone having implemented different value sets. To retrieve codes and their associated displays, which is like the preferred term of a code, an expand operation may be performed on a FHIR terminology server, and this is known as value set expansion. Some value sets on the NCTS include the same content as a reference set, and the only difference in this circumstance is the format that the subset is presented in. In general, the NCTS publishes value sets that support clinical information specifications and implementations at a national level. So let's look at a value set resource. Here's a screenshot of the FHIR rendering of the adverse reaction type reference set. I've included the API call or request that was used to retrieve the resource, and we'll go through that in a little bit more detail later on. However, do note that the last number is the reference set identifier. There is metadata at the top of the resource, and the expansion down the bottom contains references to the code system, code, and the preferred terms. One of the reasons that the FHIR approach has become prominent is that resources have a simple, extensible structure that can make implementation easy. As mentioned earlier, not all subsets are published as both reference sets and value sets. However, it's important to note that all simple type reference sets are available as a rendering of a FHIR value set expansion. The FHIR specification recognizes that SNOMED CT contains subsets and allows API calls to be constructed that uses the reference set ID to locate them. This is an example of an implicit value set, which is referred to by the URI for the code system itself. For SNOMED CT reference sets that are available as an implicit value set, they will be specified by adding a query portion to the SNOMED URI to define the scope of the content. This table shows examples of the types of implicit value sets that can be generated. We also publish value sets of simple type reference sets in JSON and XML format for ease of access. A number of composed FHIR value sets are published on the National Terminology Server to support HL7AU FHIR profiles, agency FHIR profiles, and future agency CDA specifications supporting My Health Record. Some examples include the Australian States and Territories value set, which is shown in the screenshot here, and the Australian Medicare Benefit and Claim Category value set. Here we have a snapshot of part of the AU immunisation resource, which shows that the Australian Medicines Terminology Vaccine Value Set or the Australian Immunisation Register Vaccine Value Set can be used to record the vaccine administered to a patient. Now for some examples of how value sets can be used. Value sets can be interrogated by using FHIR operations in an API client like Postman. The expand operation can be used to return a set of values matching a set of parameters supplied so that you can then go on to select a value for data entry in a UI. When the expand operation is executed on a given value set, the FHIR terminology server will reference the code system for each code in the value set and retrieves the information about the code from the code system resource in real time and then returns this as an expanded value set. So essentially, the value set is a reference to codes in one or more code systems, and if the code description happened to be changed in the code system, then the value set expansion will display this new description despite the actual value set not being modified. The validate code operation can be used to determine if a code is present in the set of codes defined by the value set. The operation will return a true or false result as shown in the Postman grab here. You have the option of checking whether the provided display text is correct for the given code as well. So in this example here, I have asked if the SNOMED code and display of hypertension with a spelling error is a valid member of SNOMED. And the result gives us an indication of false, noting that the code exists in the value set, so exists in SNOMED, but that the display provided is incorrect. The link on this slide will take you to the NCTS website where you can download the NCTS Postman environment and some example Postman queries to play with as well. We'll take a look now at how to access subsets on the NCTS. Reference sets and value sets, along with the general terminology content, are developed and published monthly. There are a couple of different ways that subsets can be accessed. Reference sets can be viewed on the Shrimp terminology browser and can also be downloaded from the NCTS website in TSV or FHIR format. The TSV format is a quick way to download and view a set of codes contained in a reference set. The RF2 bundles that contain SNOMED and AMT are also found here. However, all content accessed on the NCTS website requires a license to do so. Value sets can be accessed via the National Terminology Server and also require an NCTS license and a conformant terminology server like Onto Server or an API client like Postman. The National Syndication Server is also provided by the agency. It's a programmatic syndication interface that allows automated content downloads. Both RF2 release bundles and pre-built Onto Server binary indexes are available in the feed. More information is available on the NCTS website. Here is what the RefSet viewer in the Shrimp browser looks like. I've selected the adverse reaction type reference set from the list on the right, which is number 1, and members of the reference set are shown in the middle, which is number 2. I've selected the concept allergic reaction, and I can see the hierarchy view of that on the left, or number 3, which shows all its parents and ancestors and immediate children. Any of these concepts that are also members of that reference set are highlighted in green text. It's worth noting as well that you can only view 20 concepts at a time in the list preview of the reference set, and you'll need to scroll through the pages to view all of the concepts. Looking at the NCTS website, the access set of pages is where you can download the data, and just noting that you need to log in to be able to do so. The reference sets page allows you to search for a particular reference set, and when you click on the icon in the view column, you can read more about the description and scope, whether it's bound to any clinical information models and any other related metadata. If you were interested in downloading the RF2 bundle, you can also find it on the access page of the NCTS website. Reference sets are located in the content folder, which is contained within the RefSet folder in the bundle. Please refer to the SNOMED CT release file specifications for more information about the file structure. There is a link on the slide here to the Hotspot program, which displays the FHIR ValueSets available on the National Terminology Server. Here you can view all available value sets as well as a value set summary, which includes the URI, version, status, and OID. And from here you can also access the full value set resource or view an expansion of the value set. I will note that there are some circumstances where a value set will not be able to be expanded here as well. The Common Languages in Australia value set cannot be expanded because the BCP 47 code system that it refers to is not yet defined as a FHIR resource. And also, any value sets that contain SNOMED content will not expand here because the browser software doesn't currently support authentication. Value sets can also be accessed using an API client like Postman, which we talked about previously, and SNOMED value sets will need to be expanded using this method so that authentication is possible. We have included a number of resources here that you can access at any time for further information. So the NCTS contains a lot of useful documents, particularly in the document library, including the SNOMED CT-AU development approach for reference sets, the SNOMED CT-AU technical implementation guide, and the SNOMED CT-AU sample scripts. There are also a number of presentations on the NCTS website, including the SNOMED CT-AU hierarchies, introduction to the FHIR specification, and basic FHIR terminology services. If you're after any more information on FHIR specifically, you can visit the HL7 website on the slide here. Thanks for taking the time to listen to this presentation. If you have any questions, please feel free to reach out to us via our Help Centre. The details are on the slide here. Thank you.